Hello and welcome to this short video where we're going to see what is soft and hard linking. Just like in case of Windows where we have got, let's say, multiple files, and sometimes we want to create shortcut, like we want to create a shortcut of a file and put that on our desktop. The same concept goes in Linux as well, but we take it a bit further and we divide it into two types of shortcutting, if you call it, in case of Windows environment. But in Linux, we do not call it shortcuts, we call it file linking. And there are two types. One is soft link types and the other one is hard link types. So one is soft and the other one is hard. So how do they differentiate between one another? Well, in case of soft link, you see, if we have got a file, let's say ABC, and we want that this file we should create a shortcut for this file, or maybe a link for this file by the name of let's say XYZ. Then what we really do is that we create a link, a logical link that points XYZ file to ABC file. So the entry that we see in Linux is something like XYZ and it is pointing towards ABC. This XYZ file, it itself contains nothing except the pointer information that is pointing towards another file. While in case of hard links, the things are a bit different. And this is where the concept of inode comes in. You see, inode is kind of a data structure or database. So inode is the database that holds the information about the file, but not its actual contents. And we can see the information about the file by using the command state and then the file name on a Linux system. And what it shows us that what is the owner of the file, what is the group of that file, when was that file was modified, access, and also the inode information, which is you can say is kind of identifies that what is the block of the starting block of the file on a hard disk. If we have got, like, maybe this is our hard disk and it is divided into multiple blocks like this one, and let's say if we have got a file which is taking, let's say, these blocks. So the file is starting from this block, some data is put over here, some data is put over here, here and here. So it is taking 5 blocks. Now this first block where the file is starting, this is called as the inode. Now when we create a file, what we really do, or what operating system really do, is that they create a file, like file allocation table is holding information about files. So in file allocation table, if we create a file, let's say ABC, then what ABC really does is that it points towards this inode over here, which says that this is the first block and afterwards the complete data is here. So files that are placed in file allocation table, they are not containing as such the data, rather they are just pointing towards the inodes or the blocks on the hard disk. Now in case of hard links, what happens is that, let's say if we have got this file, let's just call it ABC, and we want that another file or a link should be created which is of the type of hard. Then what really happens is that another file is created in file allocation table, but this time the file is not pointing towards this file ABC. Like in case of soft links, the file points towards another file, but in case of hard links, the file does not point towards another file, rather it points towards the inode. So when we look at the inode information of file ABC and XYZ, we will see that both are having the same inode information. But in case of this one, since it is a separate file and it is just pointing to another file, we'll see that the inode information of this file is different than the inode information of the other file that it is pointing to. Now you must remember this thing, that while you are creating hard links, then since the two files point to a same inode information, then remember that this has to be, that both of these files has to be on the same disk, because if they are not on the same disk, then inode information will get changed. Of course it makes sense, because if we have got, let's say, a block over here, then no matter how many files are pointing to it, the value will be the same. But if we have got an other disk over here, and we are trying to kind of making out that this file, let's say LMN, so this file is, our intention is to point it to this node, inode, but this file itself, it is residing on this disk, which is a different disk. Then the inode information of this disk will be totally different. It will have totally different block numbers than this one. So remember that in case of hard links, both the files have to be on the same physical disk. This concept is also known as cross device linking. So in case of hard linking, this cross device linking is not supported if we have got two different hard disks. But in case of soft links, we can create a file onto a different disk and point it to a file which is residing on a different disk, or which is pointing to a different disk, because it's just a pointer. So cross device linking is supported for soft links if there are different disks. Also, for your information, I can share this information that more or less this inode information, it takes around 1% of the actual disk usage that files consume. So it's like if you have got files that are consuming, let's say 100 GB, then you can guesstimate that around 1 GB of that space, it will be consumed, or it will be taken up by the inodes. Now let's head over to the terminal and see how we can create these hard and soft links, and what is the inode information. So here we are in the terminal. I'm using Ubuntu, and if I do an ls over here and do a pwd, that which working directory I'm in, we see that I'm in my home directory, and let's try to see the inode information of this example.desktop file. If I do ls-l, which gives us the long listing of the files, but if I do ls-il, then where this I stands for inode information for directories as well as for files. So once I do that, I see that example.desktop file has got an inode number which is 301971. We can get some detailed information about example.desktop file by typing in the command state and then example.desktop, or maybe I need to execute this command using sudo. It should not be executed by sudo. Let's try to do that. Maybe I need to type in the correct password. Alright, so state command is not found in here. Maybe this Debian distribution is not supporting it, or I have not installed the package. But we can install this state information, and I believe in Red Hat based distribution this state command is available by default. Or it's not state, I believe it's stat. Let me try this one with stat. I believe it was stat. My mistake if I said state. I typed the wrong word. Maybe I confused with something else. Anyway, stat shows us the information about the database of the file. So if I press enter, we see that the name of the file is example.desktop. Its size is around 8.4 kilobyte. These are the blocks that are there, and this is the inode information, who is the user of the file, and group ID, as well as the access and modify and changed information. So what I'm gonna do, let's just try to create a file. Let's just do touch, and let's call it file number 1, and also create another file file number 2. Now let's see the state information of both these files by typing in wildcard mask, and we see that file number 1 has got inode information, which is this, and file number 2 has got inode information, which is this. Now let's create a hard link against file number 1, and what we should ideally be seeing is that the inode information, since the other file will be pointing to the same block on the disk, the inode information should be the same, but files will be two different files. So the command is very simple. It's just ln, which is short form for link, and then afterwards the file that we want the link to be created from, which is file 1 in this case, and then the link that we want to create. Let's just call it linked 1. Once that is created, if I do ls minus l against linked, we see that indeed a file exists, and if I do add a flag of -i, we see that the inode information of linked file is the same as that of inode information of file 1. So essentially now there are two files, file 1 and linked 1, which are pointing to the same block or same physical location on the hard drive. Now if I edit this file, let's say linked 1, and I add some, let's say some data in here, and I save it, and if I do a concat or look at the output of file 1, we see that indeed data has been put in here. Now let's try to create a soft link by using the command ln, and then for soft linking we use a switch which is -s, and then again the original file, which is file 1 in this case, and let's just call it soft link 1. So once we do that, and if I do ls minus l against let's say soft link 1, and rather look at the inode information of this file as well. So what we see is that, you see, even the color is different, that this is just a pointer. There's a file, of course, it is in file location table, but this file is just pointing to a different file, and we see that soft link has a totally different inode number than that of file number 1. But in case of hard link, the inode number were the same because these two different files were pointing to the same actual physical location on the hard disk. Now what I can do is that let's try to change this file name. Let's try to change it to file 1 to maybe file 3, and let's have a look at the value of softlink one more time. Now we see that since this was a file softlink 1, it was pointing towards a different file, file 1, which does not exist anymore because we have changed it to file 3. So the link is broken now, and that's why it is showing it in red color. Let's also look at the file sizes. So if I open up, let's say file, since we have changed the file 1, so let's move it back to file 1 so that it will be easier to see. So I type in file 3 and I move it back to file number 1, and if we have a look at the link information, the link has again come up because now the file exists. So if I open up this file 1 and let's just yank this and paste it a couple of times so that we have some considerable data size of the file, And if I do now ls minus l for file 1, we see that its size is 720 bytes. But if we have a look at the information or the file size of softlink1, which is also a file, we see that it's only 5 bytes. But in case of hard link that we have created, which is file number, what was that file? File 3 or what? Or linked one? Okay, so linked one was the file which was linking towards to the inode information of file 1. So if we have a look at the contents or the size of linked 1, it should have the same value as that of file 1, which is of 720 bytes. So let's see that. And indeed we see that since both of these files are pointing to the same physical data on the disk, so their size has to be the same. So well, that's all there is to it as far as soft and hard file linking is concerned. Now you know that what are the soft links, how we create them, and what are the hard links, and what is the significance of hard linking. I hope you have learned from this video, and I would like to thank you for viewing.